I'm Divya, working as an assistant professor in the Department of Biomedical Engineering at Sri Shanmuga College of Engineering and Technology. As a continuation of last video's topic, mesh analysis, we'll learn some of the numerical problems related to the mesh analysis today. So before that, let us have a quick review of the last mesh analysis video. So here we need to know the Ohm's law and the Kirchhoff's law. So Ohm's law states that V is equal to I into R, I is equal to V by R is equal to V by I. So this is the Ohm's law triangle, and you have to apply the Kirchhoff's law after it. So Kirchhoff's voltage law will be used in the mesh analysis. Sum of voltage drop is equal to sum of voltage rise. So in formulating mesh analysis, we need to assign mesh currents to the each mesh. We need to assign mesh current to the each mesh. So this is the circuit for illustrating the mesh analysis, right? Here you need to assign two mesh currents for each mesh, I1 and I2. And you have to apply the Kirchhoff's law in the same manner here. So after applying the Kirchhoff's law, you will get two equations. You will get two equations like this. And by solving these two equations, you can get the value of and I1 and I2. So the previous equations, equations can be written in the matrix form as so you have to write the or I in the form or I is equal to V. So resistance can be written as R1 plus Rx. Coefficient of I1 is R1 plus Rx, right? The coefficient of I2 is minus Rx in the first equation, and the second equation, coefficient of I1 is minus Rx, and coefficient of I2 is Rx plus R2, which is equal to VA minus VB. So in another way, this can be written as I1 I2 equal to inverse of this matrix into VA minus VB. So this is the matrix form. This is the matrix form in which we can write the equations, which will be easy to find out the currents. Let's see a numerical example for mesh analysis. So the given question is write the mesh equations and solve for the currents I1 and I2. So you need to apply you need to write mesh equations and solve the currents I1 and I2. I1 and I2 are nothing but the mesh currents. I1 and I2 are nothing but the mesh currents. So here you have to apply the mesh analysis, right? So for applying mesh analysis, first you need to mark the meshes. So here I'm marking as A, B, C, D, E, F. So A, B, C, F is the first mesh. You have to apply Kirchhoff's voltage law. So here you can find out two voltage sources, right? So voltage across the voltage source can be written in the one side of the equation. So the current flowing through this voltage source towards the positive terminal. So you can write as plus 10, and here looking into the voltage source, the current flowing towards the negative terminal. So you have to write as minus 2, and voltage across the resistance can be written in the another side of the equation. So voltage across the 4 ohm resistor is 4 into I1. Voltage across the 6 ohm resistor is 6 into I1 minus I2. 6 into I1 minus I2. So this is the first mesh equation. And what is our second mesh? B, C, D, E is our second mesh. You have to apply KVL in the second mesh. Here we can find the two voltage sources. So in both the voltage sources, the current I2 flowing towards the plus terminal here too, across the 2 volt source plus 2 and across the 20 volt source. So it is plus 20. And what about the current flowing through the another resistances? You have to write in the another side of the equation. So 6 into I2 minus I1. Here you can look at the difference between these two equations. The current flowing through the 6 ohm resistor, while writing in the equation above, mesh equation for first mesh, you have to write as I1 minus I2. While writing the equation for second mesh, you have to write as I2 minus I1 plus 2I2 plus 7I2, which is equal to 2 plus 20, which is equal to 2 plus 20. Now we need to solve the equation number 9 and 10. So for that, we have to simplify the equations, right? So how to simplify the equations? So we have to look at the coefficients of I1. So what are all the coefficients of I1? 4 and 6. 4 plus 6 is 10. 4 plus 6 is 10. So 10 I1 minus, so what are all the coefficients of I2? 6, only 6. So minus 6 I2 is equal to 10 minus 2 is 8. So this equation can be marked as equation number 11. And you need to solve the equation number 10. So what is the coefficient of I1 here? Only 6. So this can be written as minus 6 I1. So here the sign of I1 is minus, right? So minus 6 I1 plus, so what is the coefficient of I2? 6 and 2 and 7. So 6 plus 2, 8 plus 7, 15. So 15 I2, which is equal to 2 plus 20, 22. So by simplifying the equation number 9 and 10, you can get the value, you can get the equations 11 and 12. Now solving these two linear equations, you can get the value of I1 and I2. You can get the value of I1 and I2. These are the mesh currents what we need to find out. So by solving the equations, about two equations, you can get the value of I1 is 2.2 amps and I2 is 2.35 amps. So these are the two mesh currents what we need to find. So after finding these mesh currents, you can find the voltage across a particular element by using Ohm's law, or current flowing to the particular element by using Ohm's law. Thank you.